Good morning. Hopefully you guys have been getting on okay with the electricity tasks I've set you, and hopefully you're feeling confident that you've understood them. Today I want to talk to you about wiring, and we're going to be looking at what we call domestic electricity, which is electricity in our homes. And I'm sure you're familiar with how a plug looks here in Egypt. Okay, and when you want to connect your TV, or this is from my laptop right now, into the mains electricity, I've got these two pins here that connect. Now, I don't know if you've ever wondered what the purpose of these kind of pins are and what they're doing, but essentially, just like anything else that you connect into a circuit, a lamp, a resistor, a battery, there's always going to be two connections. So my laptop's got two connections too. One of these is carrying electricity in from the power station, okay, through the wall of my house into my device, and the other one is going to be carrying the electricity out. Okay, so we've got two pins here. Now, obviously, these pins need to be made from a good conducting material, so they're made from a metal. The ones I'm going to show you in a minute are made from brass. Okay, obviously, the rest of the casing we don't want to be able to conduct. So I want to be able to touch the wire and the plug without getting electrocuted. So that will be made from hopefully pretty sturdy, tough plastic, because we don't want it to break open and expose all the conducting wires inside as well. Now, because the GCSE that you guys are working on is a British qualification, rather than understanding these Egyptian two-pin plugs, you need to be more familiar with the British three-pin plugs. Okay, so you see the plugs here, there's a different color to the metal. Okay, these ones, as I said, are made of brass. It's a good conductor, okay, as most metals are. Not only that, sometimes when you plug these things in, you can get sparks as electrical current jumps from the conductors within the wall to your plug. Now, what we don't want is for this to kind of corrode the metal and to cause it to oxidize. So brass is very good for that. So we tend to use brass because it's hard, a good conductor, and it's not going to react chemically if it gets hot, which might happen if a lot of current flows or if a spark jumps. And as we talked about with the other plug, it's got a tough plastic casing here as well. Now, obviously, the big difference we're looking at here is that this plug has got 3 pins as opposed to 2. So what we need to be able to explain is, well, what's the purpose of the third pin? Because these 2 pins at the bottom, these are the pins which bring in electricity from the power station and return it. So what's the job of this third pin here? Okay. Well, what we're going to do is we're going to open up one of these 3-pin plugs. Now, this, just to kind of show you, this 3-pin plug I'm looking at here is actually part of the kettle. Okay, so I'm going to open up this plug and we're going to look at what's inside it. So I'm just going to move my laptop screen down so that you can see it a bit better here. And hold on. I've already unscrewed 2 of these just to make it a bit quicker. So there's normally 3 little screws at the back of here. If you take them out, and you can remove the plastic casing. So I'm going to turn it upside down. Okay. So we're looking at it from the back of the plug now, and I'm going to pull off this, and we'll see what's inside. So, oh, sorry, wrong place. Now, first thing, bit that fell off. There's something called a cable grip, which is attached here at the bottom of the plug. Oh, let's put it in a better place. Now, the main purpose of this cable grip is it's going to push down on the cable and stop it getting pulled out. Because what we don't want is for this cable to get pulled out and expose the wires inside. Now, let's make it so you can see nicely. Now, you can see that within this plug, there are 3 colored wires. Okay, we've got the brown wire, the blue wire, and then the yellow and green wire. Okay, now the brown wire is called the live wire. This is the wire that carries electrical current into your device from the power station. The blue one is called the neutral wire, and this carries the electricity back to the power station. Okay, we've also got this green and yellow wire going to the top pin. So coming to this pin up here, we've got this green and yellow wire. Okay, now that's the one that's connected to this top pin here. Now, that's called the earth wire, and that's not a wire that carries electricity into the device, so into the kettle in this case, or out. That's actually there for safety. Okay, and we'll talk about that one in a minute. The other thing that you're going to notice is we've got some little component sitting here. Okay, now actually, if you push in on the pins, you can in some plugs. I don't know if this one doesn't seem to. Yeah. If I push the pin in, I can actually remove these wires individually from here. Okay, I'm not going to now because it would take me too long to reattach them. But each of these little pins you can see has got a screw on them, and you can screw in each of the wires to attach them here. Okay, so at the moment they're all attached, but if I was to unscrew these little screws, I could pull those wires out. And that's something that sometimes you have to do if you've damaged the plug and you need to put a new cable in. Okay, now this little cylinder here is called a fuse. Okay, and a fuse is another safety feature in a plug. It actually contains a tiny little piece of wire which will melt if the current gets too high. Now, we'll talk about fuses in another lesson, but I want you to notice that the fuse is attached to the brown wire here, okay, which is my live wire. So that's where the electricity flows from the power station in through the wall of my house and into this kettle. Okay, so it has to go through this fuse. If too much current goes through there, such as a power surge, or if there's a problem inside the kettle itself, then that fuse will blow. Okay, when I say it blows, it means that the little wire inside will melt, and then no more electricity will flow into that plug. Okay, so electricity comes in through the live wire, through the fuse, goes into the kettle, and then comes back out along this blue neutral pin. Okay. Now, one of the things you need to be aware of for your part of your GCSE is how plugs can be safe or unsafe. So at the moment, okay, this one looks like it's all wired up correctly, okay, and all the bits are there, other than when I opened it up, this cable grip has come off, this piece of plastic that should be sitting there holding the cable in place. Now, some common problems that you might see with plugs, well, one is damage to the casing. Obviously, if this piece of plastic here becomes damaged and there's holes in it, gaps in it, then it would be possible that you could touch some of the metal conducting parts of this, and then you can get a shock. Now, if the appliance like the kettle is working correctly, you shouldn't ever be able to get a shock from the earth pin. Okay, but you could get a shock certainly from the live wire and sometimes from the neutral wire as well. Okay, so if there's damage to the casing, that's going to be a problem. If the cable grip is missing, then it's possible we could pull out this cable. And if we pull out the white cable, which actually has got all three of the wires in, then maybe we start pulling out some of the coloured wires inside, the neutral, the earth, and the live. And those ones have only got quite thin plastic around them, okay, that insulation. And if that insulation comes out, it's possible then that those wires can be exposed. So I'm going to give you an exercise in a bit to look at, where you look at some different plugs, okay, and you're going to try and identify what might be wrong with them, okay. So for example, the fuse here. Fuses are made for this appliance, so the kettle has got a certain amount of current it's supposed to run on. Okay, if it exceeds that, this fuse will blow. So you've got to make sure you've got the right fuse for the appliance. And what you shouldn't ever do is, let's say your fuse blows, I shouldn't just put another piece of metal in here to replace it. So let's say this fuse blew, but I want it to work again. I could stick a little piece of metal, like a nail or something, between this contact and this contact. Well, in theory, it will work. The problem is, if the current gets too high because there's a fault in the appliance or a power surge, then that's going to cause maybe the wires to overheat, possibly to melt, a fire, things like that as well. Okay. Now, actually, this appliance doesn't really need to have an earth wire, because what the earth wire does is it connects the actual appliance itself, okay, and the casing of the appliance to the ground. Okay, so that green wire there is not taking electricity to the power station or back. What it's doing is it's connecting the appliance, which in this case is the kettle, okay, to the ground outside. And what that means is, if there's a fault inside the appliance, inside the kettle, and the kettle becomes charged up for some reason, okay, then those electrons and that current can escape to earth through this earth wire. So the earth wire is a safety feature. Now, this kettle doesn't really need it because its casing is plastic. And therefore, even if for some reason, let's say the live wire inside touches the casing can't become live because it's an insulator. We say that it's doubly insulated. It's doubly insulated because one, all the wires have got insulation around them themselves, but two, the casing is insulated. Okay, so actually, although this has got an earth wire on the third pin, it doesn't really need it because it's plastic. It's doubly insulated. What you should find though, for appliances that don't have a plastic case and aren't doubly insulated, so those things like a metal toaster or a metal laptop, they should all have an earth wire, and that earth wire is basically protecting the user so that the casing doesn't become live. And what we'll talk about in a subsequent lesson is how, if the casing does become live, the electricity will flow out of the kettle along the earth wire, and that will actually cause the fuse to blow. Okay, but we'll go into a bit more detail with that later. Okay, right. I'm going to get you guys to have a look at a diagram of this yourself in more detail, and then you are going to answer some questions. Okay. If you have any questions about what I've just talked about, or what you see in the kind of questions that come up, can you please either send me an email or put your questions in the stream on Google Classroom.